Thanks, everyone. I know everyone is fed and happy, probably. You just had lunch. So hopefully not too much food coma, and we'll give you enough to compete with the digestion. My name is Lasse Clausen. I'm the founder of 1KX. We're an early stage token network fund, so we're a venture capital fund that invests exclusively actually in digital tokens. And maybe we make the round a little bit, introduce yourself and your project or your company and what you're working on.
Thanks. Yeah, so I'm Sam Williams. I founded the Arweave protocol, which is a permanent information storage system. Before that, I was doing a PhD in distributed operating system design. But nowadays, I focus on how we can make information permanent.
Great. Hey everyone, Devin Mitchum from Google. I actually live here in Singapore and cover some of the Web3 strategy and partnership work we do here in Asia. I've been at Google about 19 years. I used to build our data centers. That's what brought me to Singapore, bought the land out here. And the past 6-7 years, really just deep in the Web3 scene here in Singapore, and excited to be on this panel.
I'm Dominic Williams. I'm founder and chief scientist of the Dfinity Foundation. Dfinity is the largest contributor to the Internet Computer blockchain. The Internet Computer blockchain is the first and currently the only world computer blockchain that's capable of hosting mass market social media services on chain, for example.
In a few sentences, how would each of you define Web3? Maybe Dominic, you start.
So I think,
what is Web3? I know nothing about it. Explain it to me.
Well, firstly, I think it's fair to say that the meaning of Web3 is evolving in real time. So, I'm going to have to describe Web3 from my own perspective. I think Web3 is something much more profound than just NFTs. I think Web3 is about reinventing the internet ecosystem so that online services run completely from blockchains in new forms, in which users ultimately become part owners of the services they use and part of the team, and where these services become tokenized naturally and take new forms, where, for example, a chat application running from a blockchain will blend with DeFi, for example, allowing users to send things like tokens and NFTs with chat messages. But they'll run in a fully decentralized way from the blockchain in the mode of protocols. And the next internet, the Web3 internet, is going to be incredibly rich and exciting. Social media will blend with DeFi to become SocialFi, gamers will blend with DeFi to become GameFi. These will blend in turn with the metaverse and so on. So I think Web3 is going to be a very profound and transformative new phase of the internet that will fundamentally change the nature of online services and the nature of users' relationships with those services.
Devin, what's your definition of what is Web3?
Man, my favorite question. So I would say Web3 is really a narrative, and maybe this goes back to my day as a big believer of Linux, BSD. But if you think of open source and just the principles of computing and knowledge, if you draw that out, in my opinion, as a line and a color spectrum and a rainbow of just content and identity and provenance, in my opinion, Web3 is this just exploding spectrum of a broader arc. What is that? Not sure, but I think it started with crypto primitives, and I think recently, and I think a lot of us here today, are really seeing more mutations of that same spectrum. And what is that? Is it digital assets? Is it JPEGs? Is it art? Is it gaming? Is it digital swag? But I think there's this really long intersection of of broader computer science principles that kind of underlines Web3.
Sam, anything to add? What's your definition of Web3?
Yeah, I think that probably the most important thing about Web3, as far as I'm concerned, is that the services that we can offer through it are trustless. So we're able to offer web services to users where they don't have to trust a company to render it for them. And when we think about the world around us, we see that everybody appears to hate big tech in the mainstream world. And the reason that they do is because basically they've learned to distrust the companies. And Web3, to me at least, and I think to quite a few people in the technical side of the space, is yes, there is some tokenization. That's something you can do with it, but that's a kind of sideshow. The real deal is that you're able to build services where there's no company intermediating the experience between users and the service and other users. So a simple way to think about this would be, what if we had a social media platform in which there was no central arbiter? You could have a public ledger of speech where anyone was guaranteed the right to speak in a way that just isn't possible in Web 2. In Web 2, basically, as a nature of the protocols itself, all of the services have to be rendered from single places, like physical places in the world, and those physical places have owners. And the person that owns those places gets to decide what's on the website. Like Twitter.com has a bunch of servers. If Twitter.com decides that you don't get to speak today, good luck. Sorry, you don't. So I think that the real revolution will be that we can build web services that respect people's rights using this system.
To Google specifically, what's Google's view on Web3 and how are you guys getting involved?
Yeah. So I'd say there's a very broad answer here, but from the Google Cloud side, where I sit here in Asia, we really see this evolving trend really of just computing, right? And if we think more broadly, and especially to Sam's points, we've supported a lot of startups here in the region for the past couple of years that are building on Web3, that are Web3 native companies. And this might start as crypto exchanges, it might be automated market makers with websites, gaming stacks. But when it comes to Google, as the Google Cloud side of the business, as an infrastructure, picks and shovels provider, we think this very much ties into our narrative, which is about open source software, developer choice in terms of running compute platform, and ideally tapping into maybe more interesting themes such as sustainability, provenance, and redundancy and uptime, right? Almost all the principles of Web 2 in terms of the challenges of preventing maybe bad actors, DDoS and the like, but then how do you also serve that in parallel based on the Web3 primitives, right, of censorship resistance, of permissionless networks and permissionless public ledgers. And I think it's the combination of those on the Google side that we just find incredibly fascinating.
So yeah, there's this thing that actually a lot of the infrastructure that runs Web3, a lot of the nodes, et cetera, is actually run on AWS and Google Cloud. And then we've had some smaller providers already sort of arbitrarily shutting down. Hedge is a famous example. Once they figure out that you're mining there, they just shut you down. So I do think that at the moment it's also Google has been very kind. They've been very nice. But I do think we still have that risk, right? That at first it's a policy decision, maybe it's a US government decision, like Google will still have to follow these laws. And that we're actually at the risk of Google have to effectively denying services to, Google still has the power to decide what kind of computation is allowed on the network or not on the infrastructure, right? And I think this is like coming back to a big reason for Web3 in general is that you can't just have a small company, a small entity, small company, but a small group of people deciding essentially, what kind of computation is allowed or not. I think this comes back to that Google has been, and AWS has been extremely helpful in providing cheap and high quality computation and storage at scale. But overall, we still have this risk, and we experience it with other cloud providers that eventually they might actually shut this whole thing down. So far, Google has been great. We've never heard of any complaints, but I think just to tie it back into kind of why Web3 is a little bit, there is actually this risk. And then this brings me to my next question where I think there's a lot of computation, a lot of data storage where actually price matters and not the data sovereignty, right? And then but then there's types of computation and types of storage where I think maybe the data sovereignty matters a lot. So I don't know if anyone has particular strong thoughts about it. I personally think for Twitter, it matters a lot, et cetera, et cetera. But I think just this, if you have any thoughts on that balance of data sovereignty versus price.
Yeah, for sure. I mean, so we built a permanent storage system with Arweave, and how do you make it permanent? Well, you have to pay for 200 years worth of storage at the present price. Then as the cost of storage declines, that 200 years expands out. If the cost of storage declines at a rate higher than 0.5% per year, you end up with more storage purchasing power at the end of any given year than you had at the beginning. So it's a highly reliable system for paying for storage for extremely long periods, but it's not cheap. We're not trying to compete on price. So we've thought a lot about this, and we think that essentially it comes down to a metric you might call information value density. So that is maybe your tweet, which is tiny, and it's kind of like what are you actually trying to do when you tweet? You're sort of trying to communicate your ideas to the maximum amount of people that are willing to listen. So the internet does that pretty well over space. Arweave can let you also do that over time. And it's extremely small data, so the value of that data is pretty high. So yeah, why not store it permanently? But then something like, I don't know, 8K video of something very boring, that might not be a sensible use for a permanent information storage system. So that's kind of the frame we use to look at it.
In general, for each of you, if I'm the permissionless innovation, this concept. So if I say, I think I've invented a new hard drive, or I think I've invented a new computation chip that I think is going to be a game changer, but I'm kind of a nobody. Maybe I'm a kid in South Africa in the basement. I've just always been good with hardware. What is the process for me to actually become a supplier of computational storage in your network? Sort of step by step, without going into half an hour instruction. Dominic, maybe if you want to start, what would be the process for me to say, me and my data storage chips, or maybe me and my computation chip, we want to be a supplier and compete to provide that service?
Well, the internet computer uses a very different model to other blockchains and also to Arweave. The best way of understanding it is that the internet is hosted by physical routing devices, and the internet computer is hosted by physical node machines. It runs on a sovereign network, and these node machines are built to a standard. So if you want to participate in hosting the internet computer, this world computer, you need to run some node machines, and it's becoming much easier for amateur node providers to participate. You essentially have to either build or purchase a node machine. You have to install it in a data center, which involves putting a software image on it and doing some steps that initialize the cryptography. And you'll run it from a rack in a data center, although in some countries now, consumer fiber links into homes might enable you to do it from a basement. The reward system is very different to a traditional blockchain. You get paid in crypto, but in constant terms with respect to real value. And probably you'll run, several node machines to achieve some economies of scale. And you don't have any control over what that node machine does in terms of what smart contracts it participates in hosting and what computations it participates in performing. It's like a kind of black box in a sense.
And so the time frame, if I'm an experienced operator, how long do you think it takes from nothing to I'm supplying computation on your network? Is that weeks? Is that days? Is that weeks? Hours?
Well, it's certainly more involved than with the process on other blockchains. So most blockchains actually run on typically Amazon Web Services and other cloud providers. So if you look at a proof of stake network, a node is just a piece of software that can be spun up on a cloud service by pressing a button, essentially. And people spin these pieces of software up on cloud services, assign some cryptocurrency stake, and so on. That means that the blockchains are essentially running on big tech. And the internet computer is a different kind of blockchain. It runs on a sovereign network of dedicated hardware, and the hardware has to be built to a standard for a bunch of reasons. So, it's going to take you longer to acquire that hardware and ship it to a data center and configure it. But there are plenty of people participating, and actually there's new simplifications to the process that are about to hit production that I think will help amateur node providers who just want to run a few nodes get started quickly.
Sam, what's the process if I want to become a supplier for storage on Arweave?
Yeah, so the typical, the idea of Arweave is, I would say, slightly closer to original Bitcoin in the sense of design. So anyone is able to plug in hardware. It's extremely easy. You just download the software, run it on your machine. Obviously, if you want to optimize, then there's certain things you would do to that machine to make it more efficient. But if you were to, for example, design a more efficient hard drive for computing on Arweave, which is definitely possible. We call them kind of weave drives. Then you just build it and then you stick it in your machine and it just runs. Another thing about the network that's kind of interesting is that while you still get sort of pools because blocks are being produced and so there's certain throughput limitation on distribution of rewards, as essentially is the case with all blockchains. The neat thing is that as a provider of storage, you can just plug in behind one of these things. And so you get massive decentralization of the data set, while the number of actual nodes is sort of less relevant.
So then Google, if I think I have better hardware and I want Google to run on them, what's that process like?
Again, make a little bit of echo, but you're saying if you have hardware?
If I say I've invented new storage hardware, a new computing chip, and I think it's better than anything Google has, what is the process to get Google to run those?
Sure, yeah, great question. Well, I could maybe answer in a traditional sense based on my experience. So again, been at Google about 19 years. And when I first joined Google, bit of a funny story here, but when I first joined Google, we didn't own many of our servers. We actually leased them. And there's some funny photos you can find out there. But when I first joined, really, computing was a challenge, right? Because you had to buy OEM equipment, branded actual hardware that had a pretty high cost, right? Branded equipment. But we realized pretty quickly, especially with the growth of Linux, that, hey, we could just contract manufacture our own servers, right? And tap into the power of Linux and really almost build servers at scale with just very minimal cost and just being very lean and intelligent. Now, I would say the longer story might be, architecture questions if you're looking at x86 or maybe the ARM curve. But I would say that maybe when it comes to the server decision, it's very much kind of a macro question, right? It's about the supply chain of the chips, the provenance of those chips. If you're security-minded, the provenance and security of the supply chain to make sure that maybe regardless of the type of compute you have the provenance and the primitives and almost the full trust from the contract manufacturer facility, the supply chain, the installation, the monitoring, and the operation of these servers, regardless of the chipset inside, but really just having not only an intelligently efficient maybe compute stack or technology, but just having really deep insights and understanding of just really the full spectrum of the stack. Because I think, again, in a Web3 context, if we're moving to the future where you have, again, public data, permissionless data, and you're looking at the blockchain, you're looking at NFTs to find trust, all of that trust really depends on the primitives, the core infrastructure, the hardware. Can that be trusted at the silicon level? So fascinating question, but...
So this was, to be honest, I'm a very biased Web3 investor, so this was a bit of a loaded question, and what I was leading to is that the Google one sounds pretty complicated, because you basically have to establish a trusted supply chain that Google trusts, and on the other hand, with Dfinity and Arweave, I can basically, with one or two more steps, I can basically plug in and become a supplier already. And the reason why that makes us as an investor very bullish on Web3 is we had one very, very large computing market where you had what is called permissionless innovation, meaning similar to Dfinity and Arweave, anyone can basically innovate on the hardware side and just plug it in and see if they can compete better than others. And it took the energy efficiency of that hardware, it increased it by 130x over a period, I think, of 6 years. And that was Bitcoin proof of work mining, right? If you look at the incredible hardware advancement that happened because anybody in the world could just innovate by themselves, plug it in, see if they're better or worse, and can compete. That was phenomenal. Like 130x energy efficiency increase in hardware is very, very rare. And by the way, this happened already from the beginning of ASICs. So it's not from GPUs to ASICs, so it only actually takes the energy efficiency of ASICs going forward. And so, forgive me, it was a bit of a loaded question, but just to explain sort of also our thinking as an investor, one reason, or the reason actually why we're bullish on Web3 is because you have permissionless innovation. As a side note also, we were mining, I think Arweave at like 4 cents with a very good setup, professional engineers. We felt extremely clever. And then there was someone in their Discord that keeps selling to me at 2 cents. And I'm like, what's going on here? So, and this seemed like a young person, was a bit of a heavy metal fan. Well, it turns out that this guy, just for some reason, was better at just running, Arweave miners. And for me, it was a very small, just a subjective experience of like, this permissionless innovation turns out, and I don't know, I think he was in Russia or Siberia, or I don't know, or Finland, but it just turns out that this kid over there was just like very, very good at mining, better than a professional fund. Maybe for both Arweave and Definity, like what is something that has surprised you on the journey of being a decentralized project? What is something that you just was an extraordinary experience, something you never predicted?
Well, we can build off your answer to the last one there. I think, the innovative nature of the miners is something that we kind of theorized would happen. Like in Arweave's case, this is a pretty interesting, property of the network. We're basically saying, well, let's just maximize the amount of data we can store for a certain price or a certain amount of value flowing out of the network. And then the miners, they just compete to do that as efficiently as possible. It's very cool to see. And they really do, it's kind of hyper competition. Like anyone can get started. It's very, very easy to get to that first. You literally just download the client, start running it on your machine. I remember doing that with Bitcoin D back in like 2013. But of course, that gets you like into the game. But to play properly, you have to like compete with these other people. And the rules are clear. Everybody plays by the same rules. And so the miners just get crazy innovative about the way that they play to the rules. So that's great to see. And if you design the rules right, then you get this amazing pro-social output, which in our case is permanent data storage for an accessible fee for users.
Dominic, anything on your side in the journey of, which is, by the way, being a crypto founder is a crazy journey, I can tell you that. Anything that stood out to you that was a big surprise?
Just the power of cryptography and mathematics. Because I got into crypto in 2013. By the end of the year, I was working full-time. And I'd previously created a computer game with some millions of users. So my first instinct was, hey, we can create Gamecoin and enable people to buy and sell virtual goods and move value between games. So that's when I actually began researching L1s, 2014. Was working on adapting traditional consensus theory to blockchain space and trying to build a blockchain that could process hundreds of thousands of transactions a second. And then in 2014, someone mooted the idea of a world computer, a shared world computer within the Ethereum community, because people were just realizing that a blockchain doesn't just have to host only tokens, right? It can also host code, computation, and data. And from that moment, I was absolutely obsessed with building a world computer. And so I started working on applied cryptography and distributed computing techniques that could build a blockchain that could host limitless amounts of computation and data, but could also host smart contracts that could process HTTP. So you wouldn't need big tech anymore. You wouldn't need cloud computing services. So, when you hear people say such and such a service is built on blockchain XYZ, what that really means today, for the most part, is that it's built on Amazon Web Services, and you just move a few tokens on the blockchain. The internet computer is able to move beyond this and host smart contracts, which can store data very inexpensively, process that data inexpensively, and even process HTTP requests. So now, the internet computer is hosting mass market social media services that where the smart contracts process and store things like chat messages. And all of that has been made possible by the work of cryptographers and computer scientists. And the Dfinity Foundation actually runs the biggest team of well-known cryptographers in all of tech. We also employed a lot of kind of engineers and researchers famous for other things. For example, Andreas Rosberg, the co-inventor of WebAssembly, was an early guy at Dfinity, Ben Lin, the BLS cryptography, and so on. And so we, have a team of like almost 300 people, which is primarily composed of R&D people, which makes things a bit difficult sometimes. But we have now just amazing amount of expertise, and so we've been able to actually leverage existing cryptography, adapt it, develop new cryptography, and just seeing how you can derive so much power from mathematics to create a protocol that can create a world computer. And the aim is we're pursuing this idea of blockchain singularity, where everything, every online system and online service in the main is rebuilt and reimagined on a blockchain and runs without anything else. No cloud services, no servers, just smart contracts on a blockchain. And when I started this journey, I thought it was possible, but I didn't have all the pieces. And it took really 6 years from 2015 to May 2021 to launch mainnet. There's just a huge amount of R&D involved. And just being on that journey and seeing the power of human ingenuity and the power of mathematics, it's kind of spellbinding to watch it. But a lot of hard work. But just bit by bit, you feel like these impossible problems can't be solved. But cryptography, I think, is probably one of the most important fields of science in the world today.
And Devin, anything you can share with us? What's next sort of for Google and Web3? Anything in particular you guys are working on that sort of is a big changer, or you basically say we keep innovating on the Google Cloud service and just make it better and easier for various web services to use it?
Oh, man, great question. So, first off, I think the title of this panel is perfect, right? The past, present, future. In my opinion, really just what is the future? At the end of the day, it's about developers, it's about users, and really just what is this narrative about, right? There's some great panels before. I think on the VC panel before, if I did with Pantera and others, I did a personal word cloud, and I heard the word infrastructure probably 15 times. And then Arthur Hayes, I don't know who was here for that session, awesome. Arthur was talking about just usability, right? Using MetaMask and looking at the ETH POW token versus the ETH current token, right? And that's a user problem. So I would just look at this again, it's just about users and really just what's possible. And at the end of the day, especially with us being in Singapore, what are the developers doing? How do they look at these primitives? Again, in my opinion, computer science is changing. It's colliding with mathematics, public key cryptography, all open source up and down the stack. And it's just, again, opening new forms of, it could be crypto, it could be NFTs, memetics, collectibles, culture, whatever. But all of this needs to be usable, needs to be available. And I think at the end of the day, from the Google side, this just ties right into our wheelhouse, right? We're really proud of the public data centers, or of the data centers we have, the submarine cables, and protecting, especially a lot of maybe the front ends, again, of that user experience. How do you protect DDoS maybe from your NFT mint page when you go viral? Say there's a high gas war. I bought some land for the other side not too long ago. How do you protect that site from bots, right? Click the sidewalks, right? That's very much kind of a Web 2 stack that we can help with. So great question, but I think it's just, there's all sorts of interesting lines and spectrums of those lines in terms of what excites us most and how we can help people.
Sam, anything that's on the roadmap for Arweave? Anything? What are you guys working on? What are you excited about as like a big next thing?
Yeah, so Arweave 2.6, we released the testnet for it this week, actually, which is a fairly major upgrade to the protocol, which essentially makes mining much more efficient in terms of data storage rather than CPU usage. So once this is done, you should really be able to just plug in more or less a Raspberry Pi into the system and mine alongside everyone else. And if you've got a sufficient amount of hard drives attached to that thing, then you should be able to mine efficiently. So that's pretty cool. We think that the energy efficiency should be something like 23x, that kind of thing. So it's it's pretty robust. I mean, other than that, we're looking at we care very much about decentralization, and one of the things that we think is underappreciated in that regard is immutability. Like you really have to have a protocol stabilize at some point. It has to do one thing and do that thing extremely well, and then people need to be able to trust it not to change again. And so with Arweave 2.6, we're sort of finessing, like, hey, we don't want to waste energy, and also we want to maximize the amount of data storage we can get for the lowest possible price. So this is just kind of more Arweave, if you will. But we really wanted to stabilize somewhere after this so that people can build on it and create, entire economies and trust that it won't change. We think this is really underappreciated in this industry. Like you see it with Bitcoin, and the economy that has been created around it is enormous. And essentially, the functionality of the protocol hasn't changed since maybe late 2010.
Right. So at some point, the calcification is actually a big feature.
Yeah, exactly.
Dominic, what's any big new exciting things that are happening with Definity that are coming up?
There's several big features that are making their way into production on mainnet at the moment. One big one, which is, I think, very interesting to people building on other blockchains, is that the internet computer is powered by this thing called chain key crypto, and the protocol's been adapted so that smart contracts on the internet computer can create transactions on other blockchains, like sign transactions without having a private key. And there's a Bitcoin integration, for example, that allows smart contracts to create Bitcoin addresses, receive Bitcoin, send Bitcoin. There's no bridge involved. The smart contracts are processing Bitcoin directly on the Bitcoin ledger, and albeit you can create some kind of local cache to reduce the cost of transferring them, but that allows people for the first time to create DeFi for Bitcoin. You can create smart contracts DeFi contracts that behave as though they were actually hosted by the Bitcoin network itself. So that's a big deal. Then the other thing we just demonstrated was the recreation of a front end for Uniswap on the internet computer, so you fully decentralize the stack. So one of the problems for DeFi and Ethereum today is that while the smart contracts are decentralized, if they're controlled by a DAO, decentralized autonomous organization, which Uniswaps are, although the rails, the underlying financial rails, are decentralized, the user experience typically runs from Amazon Web Services. And the regulators look at this and they say, well, your DeFi rails are decentralized, but wait a second, where's the user experience coming from? Oh, right, you developers are running this on Amazon Web Services, and it's your credit card that's being used. So we're going to hold you responsible for the whole thing. And that's why Uniswap delisted half of its tokens. So we kind of took that as a demonstration, Uniswap front end, re-implemented it with internet computer smart contracts, and you can now authenticate to Ethereum using your fingerprint, because there's this thing called internet identity, and you can do Face ID and fingerprint and so on. And this thing basically uses the chain key crypto functionality on the internet computer to have its smart contracts sign the Ethereum transactions, which are then relayed to Ethereum nodes. And so now you have a Uniswap front end running in an entirely decentralized way from the internet computer, where you can authenticate using a fingerprint sensor on your laptop or Face ID on your phone, instead of something like MetaMask, which is a browser plugin and served by you guys, right, from the Chrome web store. Been switched off, I think, once in the past. But so that means DeFi can now be fully decentralized. And I think that's actually a big step forward. And I think once the news about this thing spreads, I think, in the coming months, we're going to see a lot of DeFi front ends running on the internet computer rather than from Amazon Web Services. So I'm hugely excited about that.
Pulling back a bit or zooming out a little bit, we used to have a time where maybe AWS or Google Cloud was powering the Yandex taxi service in Russia, and maybe even, Didi Chuxing, you would order Didi. And last years, it seems that, we have a political we almost have a trade war between China and the US. We have a full-on war with Russia now. We saw all of the Silicon Valley-based web service providers pulling the plug on, I think, every Russian citizen, even though they're not necessarily were sanctions, but just to be safe, we stopped providing, Stripe stopped providing payment services, Visa, MasterCard stopped providing payment services. And so I think now we're going to a world where, Didi Chuxing is hosted on the Alibaba cloud, Yandex Taxi is hosted on the Yandex cloud, and then Uber might still be on, Google Cloud or AWS. And so this is, a bit of a question, but also a bit of a statement. I think as we're seeing actually, unfortunately, less global cooperation among regions, I would say roughly China, Asia, Russia, and then the West, are starting to become sort of these technology islands, which, we all think is probably, not a great quality or is not progress. I do think that this data sovereignty or this computation sovereignty, I think actually becomes extremely important again, that we have credibly politically neutral technologies that, the Chinese government can trust, the Russian government can trust, and the West can also trust as well. And so I think you're welcome to add any thoughts on that, if you think if it's getting better or worse. My experience is things are not getting better. That might also be, right? It might also be an age thing. The older you get, the more problems you see in the world.
The rumor has it that, I think, the SEC made some kind of scary arguments there because the majority of Ethereum nodes run in the US. And, mostly those Ethereum nodes run on Amazon Web Services, either directly or indirectly through Infura. So that the US government has primacy and dominion over Ethereum transactions, and there's a rumor that they're working on a mempool filter for Ethereum. So it's going to be interesting to see how that goes. And I think that the way forward is people need to make sure that their blockchains are balanced with ideally the majority of nodes outside of the US, because this battle's coming, and it's coming, I think, much sooner than people realize. Yeah.
And I think it matters that we build, credibly neutral, politically neutral technology infrastructure, because we do all benefit if the world globally collaborates versus building their own little technology islands.
Yeah, and if I could add to that point, I think it's a fascinating question, right? And the balkanization, right, of if it's compute, if it's storage, if it's services. And I think maybe as an industry, especially as a Web3 industry or people that are curious about Web3, I think the broader question is more transparency could be quite interesting, right? The state of blockchains, the state of public RPC, the state of just interconnectedness, and again, just back to those open source principles. Ideally, everything's open source code. It runs in a Docker container. It's flexible, and I think only with those primitives, and then on the side of that, just being as an industry more transparent in terms of that infrastructure, I think it can really help back to that narrative.
Yeah, I mean, it's flashing at us to say wrap up. But I would just say, look, like the point of a protocol is to be neutral, and we see that the history is full of protocols that have helped us communicate across difficult barriers. The one that actually comes to mind for me is like paper. Like paper has been used as a technology across time amongst all sorts of groups of people that are mutually distrustful. And I think we're starting to see that some crypto protocols are reaching that level of neutrality. Really, probably only Bitcoin at this point. But the instance that stuck out for me was when Ukraine offered Bitcoin as a currency to Russian soldiers that gave themselves up. Yeah. That is, people that are basically like, they're about to kill each other can use this protocol as a safe way to interact, neutrally. So I think that there is progress there, but I do kind of think that we're not moving fast enough probably on that front.
Thank you, everyone. We have to wrap up. Thanks very much.
Thank you.
Thank you.
Thank you.
Thanks.